let's get on with our webinar. Again, many thanks to Aqua Security for sponsoring today's webinar. Let us jump in now and let me introduce you to our two panelists. So if we could have our bio slide, our panelist slide.
I clicked on it, Alan, but it didn't advance.
Sometimes that happens. We will, and that is Randy. That was a great sound check, though, Randy. Oh, and you know what? I am going to just take over that. No, I'm not. Jules, can we pop that through?
There we go. There we go.
It's on now? I'm not seeing it. Yeah? I'm very sorry, guys. Who has the presenter? Is it Ronnie or Randy?
Ronnie has the slides.
Got it. Okay. Okay, we're working. Fantastic. Well, guys, just a little technical. We'll overcome that quickly. Let me introduce you to our panelists, and I think you've heard them both already. Let me first introduce Ronnie Osnot. Ronnie is VP of Marketing at Aqua Security, and he's going to be nailing down the Aqua Security side. But then we're also very lucky to have with us today Randy Hefner. Randy is VP and Principal Analyst serving both for application development and delivery professionals from Forrester Research, to be more professional. But Randy, Ronnie, welcome.
Great.
Ronnie, let me just hear you, make sure we're good.
I'm here.
On a sound check? Okay. All right, Randy, I understand you're going to take over the first part of the slide, so I'm going to hand it over to you.
Very good. So away we go. And the topic of achieving software delivery speed. Once again, it looks like there we go. Now it looks like I got control again. It keeps popping in and out of the of whether I have control of the slides. So let me.
There we go.
There we go. No, that looks like that's going. Hopefully it won't. I can see my mouse. I can see me moving the mouse, but the keyboard's a little slower. So anyhow, what we want to talk about delivery speed, and if you want to focus from a business perspective, that's why we're here. We're here for delivery speed. That's what makes us interested in microservices and containers, and so delivery speed is first, but security's got to come right along with it. And I noticed as the industry started into conversations about Docker and microservices and such, there wasn't a lot of talk about security. And so I'm glad to see that the conversation is starting to come around, because what we want to do is set up why you care about these things, but then also, and very much to the point, get around to how you can do them well. So the starting point that I like to give is just understanding how digital disruption drives the need for rapid change. And you can think of your organization as being like a big semi-truck rolling down the highway, prepared for the long haul, built to be sturdy and run and carry heavy loads, and that's all great, except that the world's changed around you, and your organization is now on a racetrack, and you're trying to drive that semi-truck down a racetrack and do these new things that you need to do, mobile apps and Internet of Things and smart home and social and big data analytics and API strategies, internal and external. But it's not only that, there's a number of other issues. You're trying to live have to live in more dynamic ecosystems with disruptive startups, new products, new competition from surprising directions, and we see this a lot, for example, in the financial world with fintech startups that basically fly under the radar of regulation because they're they're providing financial services. I mean, you really have to say that they are, but they're not holding accounts, and so they're not subject to the same regulations as banks and such. So that that's just one vertical where there are these disruptive forces that change competition, change players, or change the way that a traditional player can operate in the industry. Ask whether even the traditional players will survive in their current form. So all this stuff is happening, and at the same time, customers are demanding that you give them better interfaces, better mobile apps. There's a common bit of wisdom circulating on the streets that your customers' expectations are set by the last best experience that they had. Doesn't matter whether it was from one of your competitors or from a completely different domain. When they see that somebody can do something cool to serve them better, they expect you to do that too. And that's just one more huge domain on satisfying customers and customer experience that you need to change. So great, you got this big monolith of an organization, and you need to deliver continuous transformation, but not only continuous change to meet these demands. It has to be big change, ongoing, continual change. So what are you going to do? Option A, get big projects with more people so that you can do more simultaneous big things and more big simultaneous deployments. Or you can be more effective if you break it into that big project into small teams, independent, coordinated deployments. Okay, so I'm singing to the choir here. Of course, it's B, but that just screams out microservices. Because even if you are trying to do things in an agile way or small teams, if you still are building things like maybe you got a small team managing a line of business website that one division of a company, and there's another small team doing the next line of business website, those might be deployed as one big hunk. And you can't change individual pieces quickly. So microservices come in to help with that. But let's first define the term. And I'm not going to define the term in a way that is necessarily sort of a precise computer science dictionary definition, because I don't think that's particularly useful. If you wanted to, by the way, find a definition that you could apply to any time anyone in the industry says microservices, about all you could say is, well, something's getting smaller, and that's about it. But I think it's easiest to understand if you break it into its two parts, micro and service. And from the service side, there are two ways that the industry uses the term. It's either a component, a module, a hunk of code, or it's an API. Or it might be both together. It's a hunk of code that delivers an API. I wish the industry would talk about it only from the component side, because that's where the real value is. When you talk about microservices from the API side, you pretty much just get back to best practices for API design and pulling forward a bunch of best practices, not worst practices, but best practices from SOA. But nonetheless, the industry talks about it in both ways, so I'll go with that. The micro side, though, this is the most misleading part, because it makes people think it means small. Doesn't necessarily mean small. We'll get to that. But to help you understand it, the phrase that's most commonly used is a microservice does one single thing well. Okay, great. Well, I'm in San Francisco right now, and if I want to fly home to Dallas, that's one thing that I want done well. To the airline, it's hundreds of things that need to be done well. So the micro bit is best understood as a single thing done well from the perspective of the service user, which means that it may be a small thing, or it may be a big thing. Small thing like a type ahead API, which is about as small as you can get. Give me 3 characters, or maybe just 2 characters, and I'll give you a list of 10 things, great. Or maybe you're doing managing a small collection or updating a single entity. But it may be a big thing, order fulfillment. My mobile app developers and my web app and my kiosk developers, I want them calling one order submission service so that I can do order fulfillment in a consistent way. And if I'm implementing that service, then I want a whole other layer of services underneath that I am using, but that are not exposed to the broad world. Because if my mobile apps are using all those lower level services underneath my order fulfillment service, then they're going to fulfill orders differently than my web app developers and so on. It's going to be a mess. So micro can be big or small. The component side, let's come back to that, because here's where I say the real power is, and the reason that the real power is here is that, let's see, trying to advance this. Ronnie, can you, oh, there, okay. I think I have the clue as to when it's actually going to respond to me. Something keeps going in and out on the control. Maybe, Ronnie, can you hit page down for me once? Because for some reason, it's just not always responding to me. So I'll just call on you if I need. But anyhow, so let's talk about components, because components are the thing where you really get agility. You might, this image that I have up on the screen now, you might think of it as it's a single deployment package, one big Java web application, and it may be modular inside, but it's packaged together in one big unit for deployment. That's where the issue is, the biggest issue that microservices is going to address, because what microservices are going to do are break that into a number of individual deployment packages. There's some other ways to talk about microservices where maybe page 1 here is associated with the customer runtime component, and the two of them are sort of a microservice stack. There's some other advanced ways. I'm not going to get into all those kind of details, but once you break the application apart and can deploy individual bits separately, then now you can do more incremental change. You can have implementation diversity. Maybe the customer business logic is built with one language and the account is built with another because there's some interesting reason why it should, or there's an analytic component that's built with a different language. So you get implementation diversity, more runtime robustness because individual things can fail, greater range of deployment options so that you can put components on their own individual deployment infrastructure to scale them separately from other microservice components. So a lot of value that comes with microservices, which feeds into DevOps agility, in that the more that you are using, let's go back, went one slide too far. Sorry for the troubles here, folks. So if we can go back one slide. There's a synergy between microservices and DevOps where the faster you want to go with DevOps continuous integration, the more you need microservices. The more you want microservices for deployment agility, the more that you really need the rigor and control of DevOps. So there's a critical relationship between the two and key synergy between them. But in that DevOps environment, now you got all these different little components that you're building and deploying and running and trying to coordinate. So how are you going to coordinate all those individual components? Again, let's have some choices. You could have some off-the-shelf packaging and execution technology. You could write your own framework in your own choice of language and environment. Or there's some proprietary products out there that will call themselves microservice components, microservice products and environments, and more or less they may be calling themselves that appropriately. But what we're going to talk about and say that you're generally going to be best with is option A. And option A means OS level containers, and specifically means Docker. So let's talk some about Docker and the major elements in a Docker setup, because here's where we start to get into how you're going to do things and what kind of security issues you're going to run into. So the first bit is the microservices that you're writing and running, and you're deploying them each individually, but to deploy them, you put them inside a container image. And we'll see in a later slide more about what's in a container image. But it's the runtime elements that make that microservice work and actually run. And these containers images might be able to talk to each other, so a microservice can talk to another microservice to coordinate things. Underneath that, it's the Docker engine that is running and controlling the operation of containers, and that's running on an operating system. There are configuration files that control each of these. The operating system, well, not only just files, there's a variety of configurations, but they control operating system, Docker, how containers are configured. Well, these container images come from registries, and they can be public registries that people can download. Any of us could go in and download some container image that might have some microservice embedded in it. Or you could send up a private registry in your own environment. But these container images that have the microservices, they're also more generic kinds of container images that get combined and layered into the actual container image that you're using. So there's a variety of other kinds of images in those registries. And then there are management and orchestration tools, Kubernetes, and Mesos, a variety of different things that each have their own configuration environments. So you get all these different environments, all these different pieces, and that's what makes up a Docker environment. And here we're going to stop for a poll question.
Great. Okay, guys, our first poll question. Well, let's find out. How many of you out there are actually currently using Docker containers? And by the way, that may be not in a production environment. Maybe it's just in a QA or test environment or a development, environment. But if so, please answer. This shouldn't be too long. Yes, in production. No, but not in production. Plan to use or not at all. We'll close the voting up in just a few seconds. 5, 4, 3, 2. Last chance. Get your vote in. 1. Here's our answers.
This is kind of what I was expecting to see, Alan.
Yep, it's kind of that seems to be the MO right now, as we're still, I think, early in the adoption phase here.
Yeah, a lot of plan to use, a lot of excitement. I get a whole lot of questions at Forrester from our clients about microservice containers, Dockers, and the like. So yeah, that's great. That's interesting. So well let's talk some about what the issues are here then with these containers and Docker, and specifically the kinds of attack points and attack surfaces. So let's first look at the registries themselves and some of the questions that come up there. The first major thing is just understanding, should you trust a public registry? And certainly Docker has their registry, and there could be others, but it's a public environment, public place. Understand whether you can trust it. But more to the point is the container image that someone is pulling from a registry safe and approved for use? And does it continue to be safe and approved for use over time as it is versioned itself? How do you know that some version of it doesn't create a vulnerability, either intentionally or carry along a vulnerability because of one of the components that's inside of it? which has to do with how the containers themselves are created. So in a container image, there will be a base image, a starting point, and there may be multiple other images that are layered on top, along with, you can think of it as software that is sort of pre-installed in the image, and your actual microservice code that you want to run. So that's how things might be put into your own private registry. But does that container image comply with your organizational policy in how it's built, in the images it uses, in the components that go inside of it, and in how it is configured? Is the private image based on approved images that were taken from a public or a private registry? All of this just has to do with, are you using the right code itself? Now, if we look at more what's happening in the runtime environment, then we see a number of additional kinds of attack points. Lots of configuration that has to be done at the OS and the Docker runtime level. So are those configured appropriately? Do you have auditing over how configuration changes are made? Is the operating system appropriately locked down? The Docker engine configured appropriately? Is there monitoring inside so that you can tell whether the code inside a container image inappropriately breaks out of the image and calls down to the operating system level? Variety of security issues there. Is the image itself configured to run securely? And a key, is the image behaving well at runtime? And so additional monitoring there. Part of the configuration is, should one container trust communication from another? You certainly can have all your containers communicate via REST APIs or something like that, but you may find it more efficient, particularly in close-knit collections of containers, to have them communicate via inter-container communication mechanisms that are more direct and lower latency. So are those configured appropriately? Where is trust allowed there? Is a container allowed to talk to the outside world or not? It may be that it should be communicating only with other containers and not have network access to the outside world. And just something like, are all the containers that are running, are they authorized to run? And all of that just gets wrapped around the tooling that manages and starts your container images and decides which container images are running. So how are you going to evolve with all this kind of a mess? And I call it a mess because there's just lots of questions, and it's very easy in this sort of time of innovation and excitement about a new technology to just run after making it work without thinking about some very serious enterprise issues about security, management, governance, collaboration across the enterprise. So you need to be very intentional about your architecture and evolution for microservices. And the way that I would think about this first is focusing on layers and APIs and dependencies for service composition, understanding that as you break things apart, you're making decisions on how they communicate. You have many more things to control and understand dependencies on. So if you organize your architecture and your solution architecture into layers of components, major business services that would be accessed via APIs, and maybe implementations inside those that might need lower latency and communicate via inter-container communication and the like. So be very intentional about your architecture and build in security from the start, and be thinking both about attack protection and enablement. There's just too much discussion in the application security world these days that is focused only on attack protection, but it's also very important to understand across a calling chain of components, how does identity get brokered across those layers? Does the database know who or what role or anything at all about how the request is coming into it? Or does the database just have to trust that it's in a secure environment and process any requests that come in? Key questions that then there are reasons to answer them in different ways. For DevOps speed and quality, automation across the life cycle. Architects cannot just say, here's what you should be running in production. They have to architect for the full life cycle, the full DevOps tool chains, and how things are going to actually be built and configured to get into production, not just what's in production. All this is about design for change, to understand how you can do API design better, and focus on non-functional requirements to evolve a high quality of service platform. Do testing and more functional testing. I just saw a presentation from a major transport company that they were so serious about making sure their microservice environment worked well. They actually spent the better part of a year with all manner of availability testing and performance testing and scalability testing, but really a whole lot of chaos monkey like high availability testing. So bump it up a level, continually downsize your business change deployment. So whatever you have now, don't think, oh, we've got to go to the full high-end microservice architecture. Just think, how can we make a smaller deployment units from what we have right now, and then make those smaller, one step at a time? Because agility is a matter not only of the granularity, but also your ability to control the environment, to control the processes, and your ability to experiment, but all with reliability, so that you don't send the company into a tough situation because of your excitement about microservices. You ignored security issues or ignored other quality of service issues and wound up with the company being down for a while. And it'll be a long road to maturity, so be ready for that. Ronnie, over to you.
Thanks a lot, Randy. Let me see how I take back control here.
Sure. Hey, Ronnie, while you're doing that, let me just remind our audience, you know what? I only see a couple of questions in our question queue. So Randy just poured his heart out into this, and I had some questions. I'm sure you guys do too. Please put them in now, or we may forget them by the time Ronnie finishes, because he'll spur yet more questions. But Ronnie, hopefully you're okay here.
I'm good.
Take it over.
Thanks again. Thanks, Alan. Thanks again, Randy, for a great presentation and discussion. I think I'm picking up where you left off. And let's talk a little bit about security. Hopefully the slide will move. There we go. Very, very rapidly, just a few words about Aqua. So we're a young startup, like most startups in this space. Everything is new. Currently 25 employees based in Israel and the US. And we are already selling to enterprise customers in the financial technology, healthcare, and retail sectors. And our aim is really to secure the entire virtual container environment from development to production. And hopefully by the time I finish this presentation, you'll understand how we do this. So this is kind of a 30-foot view, a very high-level view of what we think the main issues here are from a security perspective. So when you look at containers, if you look at them as an evolution of VMs or kind of the next stage, you're looking at a magnification that's on a much larger scale in terms of speed of the development cycle, in terms of scale of just how many objects you have to deal with and how many things are happening, and as well as obviously connectivity and complexity of how the interconnected microservices interact. And so this creates a very large attack surface that's also very dynamic and quite hard to grasp. And of course, security traditionally is about stopping, right? It's about, okay, let's wait, examine things, test things, and then when we give the green light, you're good to go. With containers, and especially in DevOps environments, and the two usually go hand in hand, this approach will never fly. Things just move too fast. If security wants to stop and test the same way they used to test applications with every iteration in a continuous integration, continuous delivery environment, this simply won't work. It'll stop all development and all innovation. So clearly, a new approach is needed. So, and if you look at some of the if some of you have done some reading on the internet in blogs and various bylines and white papers about things you need to do today to secure your container environment, I called it 327 easy steps. You could put any large number on this, but clearly it's not manageable to work with a multitude of tools. Take a bunch of steps that require a very high set of expertise in security, are very time-consuming and not scalable, right? So I'm talking about things like SecComp profiles and CIS benchmarks and all the things you need to do to secure your environment, and then other best practices, anything that is manual, basically. This simply won't fly. And the example I give here is obviously of a build-it-yourself car. Yes, you can do that. It could even be fun if you have a lot of time and the skill to do that. But most of us just buy ready-made cars. And so, and we're looking at it also from a practicality standpoint. Typically, if you look at other areas where security is applied, the quality does not increase with complexity. There is a sweet spot that happens fairly early on, and if something is too complex, what happens in the end is that it's either not done or it's done in a suboptimal kind of cookie-cutter approach, which is not suited to the specific policies, workloads, and risks that are involved. Oh, and now we're on to poll number 2. Alan, over to you.
Okay, thank you, Ronnie. Okay, guys, actually, it's our final question as well. This is a great question. I'm looking forward to seeing what the answers are. Who owns container security in your organization? Is it the IT security team? Is it the application owners or the mysterious and rare DevOps team? Is it a shared responsibility? I don't know how well that'll work. Or not sure or don't know, and that's probably a real problem. And it's a real problem that we see in the space, obviously. Let's get our answers in, though, if you can. We're just going to close it off here in about another 5, 4. Come on, we're only at about a little over 50. More of you must know what you're doing with security. Let's close it off in 3, 2, 1. Jules' survey says, yeah, isn't this the problem? So more than a third of you, right, say not sure and don't know, and then about another third say it's a shared responsibility, which can be a good thing as long as, I guess, Ronnie and Randy, as long as responsibilities are clearly delineated. Otherwise, it becomes a mishmash. And then application owners and DevOps, 20% own it, and last but not least, or maybe least, security teams at 11%. Ronnie, what do you think?
Oh, I think this is very reflective of the current state. I think over time you'll see security teams taking charge more as they get themselves educated on containers, and also there will be an emergence of DevOps or DevSecOps, whatever you want to call it, people who kind of wear this hat, who are both DevOps and in charge of security. And we've seen this before in other technologies that emerged, where it's a new technology and requires specialization both in the technology itself as well as the security aspects that it presents. So a decade ago, this would have been the picture in database security, for example.
And I'll just toss in that there's from another angle of looking at the question, if any of the app team or DevOps team thinks they don't have a shared responsibility and thinks that it's all over to the IT security team, then they don't understand security. And because there's always something about the app that will contribute to or take away from the level of security across the environment.
That's exactly right. So this is a somewhat different view on the stuff that Randy presented before. I'll go over it briefly because I want to get to the solution part as well. But if we're looking at a threat landscape, and these are not necessarily real threats that already happened, attacks that already happened. We don't hear much about attacks on containers because it's all so new, and it's not. And of course, with a lack of visibility, sometimes very hard to even know that they happened. But if we look at it, from kind of a workflow perspective, there are issues with untrusted images, which is something that Randy highlighted before. The orchestration layer, obviously, as a main entry point into the whole runtime environment of how containers are deployed and run, needs to be properly secured. Containers themselves can behave in a way that is either bad for the other containers or have malicious code inside them. Again, we're looking at a stack where you have an operating system running a container engine, usually Docker, and Docker running the containers, and none of these layers is aware of what the other layer is doing, right? So an OS would know that it's running Docker, but it has no idea that containers are running on top of that. And of course, the containers themselves, the whole idea with the container is that the container thinks it's running on its own. So there is an issue there with understanding and visibility of what's going on. Network attacks is another thing where networking is becoming more dynamic, more complicated, very similar to what happened with VMs about a decade ago. So you're basically moving the network into the container space. And finally, you can have resource abuse of containers, simple things like running some kind of denial of service attack on the host itself and prevent the application from running. And finally, of course, we have the user element, especially insiders, where if they have access to the wrong thing, they can do damage either accidentally or deliberately, and this is something that a lot of our customers are concerned with. And of course, so what we do is really aim to secure all these aspects, and we broadly we are looking at two areas. One is around how containers are developed, updated, and maintained. And so this has a lot to do with managing the images, and I'll get into that on the next slide. And then during runtime, especially, of course, in production environments, there are actually several layers of security that we apply to ensure that containers are not doing anything that they're not supposed to do, and that the host integrity is maintained, and that users are prevented from accessing things that they're not supposed to access based on the least privilege principle, which is one of the key principles in security. So if we look at the images and how container images are managed, you can look at it as like there's the whole world, and a public registry like Docker Hub is representative of that. I don't know what the last count is, but I think last I heard there was more than 600,000 images on Docker Hub. It may have passed 1 million since, I don't know. And of course, most of these images are not something that you would want to use. They're private versions of various things or things that people developed on their own. And so, of course, within that, you need to select a subset of what Docker calls official or signed images or your own custom images that are approved in your environment. But then each image, before it's being deployed, needs to be vetted to make sure it doesn't contain vulnerabilities, or that if it does contain vulnerabilities, they're not ones that would damage your environment. I mean, there is a tolerance and policy on that, and that it doesn't contain any malicious code, etc. You also want to know that the images, that an image that's stored in your registry and then is passed on to a staging environment or is then run in production, that these are all actually the same image. So you want the image signed or fingerprinted, and you want to make sure that it's not tampered with and that its integrity is maintained throughout. And finally, you want to be able also to have a policy on what kind of images, based on various security parameters, are allowed to run in your environment. I'll give an example. Let's say you have an image that was clean, but now a new vulnerability was discovered that applies to this image. It's been registered in the National Vulnerability Database, and now it's suddenly the image that you had, which you thought was safe, is now not considered safe. You would want to know that, and you would want to have the tools to automatically prevent such an image, or at least alert you on the fact that this image now contains vulnerabilities, and this can happen, you know, on a day-to-day basis. Another aspect is, of course, that things have to be automated, and they have to be continuous. So, you know, scanning images for vulnerabilities is something that has been talked about a lot in the past year, and it's something that's available from various tools, some of them free, some of them paid. But the issue here is that just scanning once is not enough. You need to be able, again, to scan at every stage, automate that scan, have a policy that says what you're allowing and what you're disallowing, and of course have a database that's constantly being updated. And so what we do on this front is we integrate with CI/CD tools to automate this process, and we maintain a relationship between the registry and what images are running there, the identity of those images through fingerprinting that we do, and then we follow or track those images and their use throughout the environment to make sure that they're the same ones and enforce the policy for running containers based on that, based on those images. In runtime, the most meaningful protection that we provide is based on behavioral analysis of what containers are doing. So we're basically looking, as Randy mentioned earlier on in his presentation, one of the benefits of using a microservices architecture is that you're able to break down the application into very small single-purpose components. And so, and from a security standpoint, the benefit here is that it's much easier to understand and predict the behavior of a single-purpose component. So, you know, if I'm looking at, I don't know, a flight booking application, and you look at the whole set of inputs and outputs for that application, it's quite hard to understand what's going on. But if I break it out into pieces like, you know, the flight search engine, seating, where you choose your seat, flight ticketing, et cetera, it becomes easier, and of course, microservices break these things down even further. So when we look at a container, we can predict with a fair degree of accuracy, based on its behavior, what it's supposed to do and what it's not supposed to do. And we actually do this on two levels. We have a default profile that we apply to very common official images, like, you know, Nginx or databases like MongoDB. And so to give an example, a database usually seldom, it's very rare for a database to require outbound network connections. Usually the network connections go in, they don't go out. The queries for the database they pull, you don't have the database querying outside. And so the default profile for something like a MongoDB would not permit outbound network connections. But that's just the default. If we look at a specific container over time, we can see what its network use patterns are, whether it acts, what read-only files it accesses. We can look at whether it's running executables and which executables it's permitted to run, what storage volumes it accesses, the image integrity itself, user context, so what users are allowed to run it. A very typical example would be if you're using an orchestration tool like Kubernetes, for example, in your environment, and in production, only Kubernetes runs containers and not individual users. If you suddenly have an individual user trying to run or stop a container, that would raise a red flag. And of course, you can also limit the resources like CPU or memory usage. And we also enable environment variable encryption to keep secrets, because oftentimes that's where things like passwords are stored. So I don't know what happened to the fonts here, but to look at the deployment, it's a fairly simple setup. So we have a command center, which is basically a server which can be installed anywhere. It's actually a container in itself, and we connect that to your public or private registries. It also integrates with CI/CD tools and analytics or security event management tools. It also connects to our Aqua Cyber Intelligence service, which is the service that updates things like vulnerabilities, and also a very long list of behaviors and bad reputation IPs that we also filter. It then connects through a scale-out component that we call the gateway that allows us to scale out to address very large environments, to connect to our enforcers, which are containers in their own right, that you basically install on every machine that runs containers in your environment. And the enforcer is, as its name implies, it enforces the policy. It also monitors the activity of the containers and sends it back to the command center for reports and analytics and alerts. It's also a resilient system, so that if for some reason the connection between the gateways and the enforcer is severed, the enforcer will continue to work independently and then send the information back once the connection has been reestablished. And so the benefit of using our approach is that you really get a full container lifecycle security solution with end-to-end visibility. I didn't highlight a lot of features that we have because of the time is too short, but basically we also give you full audit trail capabilities and alerts and so forth. You can accelerate your application development and deployment. We look at security as a quality control process and an enabler, not an obstacle. You can also improve infrastructure utilization. Some of our customers, for example, who run multi-tenant environments, they can use us to enforce the isolation that would usually require running separate VMs. So they can basically increase their density of containers. And finally, of course, regulatory compliance, things like PCI DSS require a lot of these things to be monitored and audited fully. And with this I finish, and we can move on to the Q&A session.
Fantastic. Thanks, Ronnie. That was pretty deep, and I hope our audience, first of all, appreciates the great job both you and Randy did, but also it certainly has spurred questions, so that's a good thing. And let's jump into them because we don't, unfortunately, have a lot of time. Before we do, let me mention, if for some reason we don't get to all of the questions, we will present your written questions that we have here to Randy and Ronnie, and we'll try to get answers for them either to you or on the page that'll be hosting this webinar on DevOps.com, Container Journal. First question, though, is from Sujit. How are microservices different from the conventional web services? Randy, that's probably something right up your alley.
Yeah. Well, the better question is how the two might work together. So a conventional web service, and I'm just going to say API, whether it's a SOAP API or a REST API or whatever it might be, like the example I was saying earlier, it might be to submit an order. Well, that's, according to the a good way of thinking about a microservice API, that is a microservice. And this transportation company that I mentioned in my presentation, they have some of these very big things that they call microservices, but the architecture inside is what changes. Rather than being one big hunk of monolithic code, with a presentation I saw from this transportation company, there were like 30 little blue boxes inside that were each communicating via API calls in order to make up that big service. But then there might be a small service like a type ahead. And the API, the web service, that is basically exactly the same when we're talking APIs and web service, because remember I said that the microservice API usage is just about best design practices for services, but microservice components change the way that those services are built.
Got it. Okay. Next question from David Cameron, not the former Prime Minister, I suspect. How does .NET work with Docker?
There's a
Jump on another question here because we have quite a bit and not time. What do you guys like to use to manage your configurations, file or environment?
Yeah, Ronnie, why don't you take that one? That's a little deeper into to what you guys are going to look at in the security architecture, anyway.
Right. So if you look at large size, large size deployments, files have an advantage of being simple, but you may run into issues of sprawl, right? And so you need something that's higher level. We see a lot of people, using basically orchestration to, not override, but basically as a layer that really makes the traditional configuration management not redundant, but maybe less dynamic. Let's put it that way.
Okay. Here's a big question. Does the world of containers just make things more complex than the world of IT management?
The key word in that.
I'm not laughing at. Yeah, I think it's a great question.
The key word is just. Does it just do that? Well, it certainly does that. I mean, like go back to Ronnie's slide with the million car parts. Yeah, that makes it more difficult to get your car on the road. But it's the benefits that you get that counterbalance that, and some of the agility and things that I was talking about that actually make the equation work.
I agree. I think the benefits are overwhelming compared to the risks and the complications.
No doubt about it. And if you're not moving forward, you're dying. So,
but move forward carefully and in a measured way.
Yep.
Of course.
Guys, with the three of us can probably talk about that alone for the next hour. But we're at the top of the hour, and we need to be mindful of people's and respectful of people's time. So I'm going to need to call a wrap on today's webinar right now. Randy, Ronnie, thank you for a fantastic webinar on a very, very hot topic. Hopefully we can do this again sometime in the future and pick this up. Of course, Ronnie, I think Aqua had an article on Container Journal recently around
right. Yes.
container security, and I'd recommend everyone go check that out. And thank you all very much for attending today's webinar. Ronnie,
Thanks,
Randy,
Alan.
thank you. Thank you. Aqua Security, thank you. From DevOps.com, thank you all for attending. This is Alan Schimmel, and we hope to see you again on another webinar soon. Have a great day, everyone.